A very good morning to all and welcome to my class. Today we are going to discuss our paper, right? So, I hope you all write your paper very well. Okay. So, let's discuss some important questions, or I try to solve each and every questions in your yesterday question paper, right? And try to understand the concept behind this and in which question you are basically facing some problem. We are going to see this as well, right? So let's start with the today's session. That is a paper discussion basically. That is of 7th May paper. You already wrote your paper, and we are going to discuss the solution of this chapter, right? So let's see what is this. I hope all of you, some of questions are very easy. So these questions are easily attempted by you. So the first one is, this is from paper one, right? So first question is, in this question they are asking the correct order for the first ionization potential among the following molecule. So you have to find out the correct option for this, right? So what is the correct answer for this, beta? Yes. The correct order of the first ionization enthalpy. So let's see. If I'm talking about F negative and Cl negative, we know that F negative and Cl negative, fluorine and chlorine. Out of fluorine and chlorine, the more amount of energy is required to remove the electrons. This is the fluorine in case of chlorine. So chlorine is nothing, but it will become 2 comma 8 comma 8, or we say it will become 3p6. That is a fully filled, right? So this will become 3p6, okay, and this will become 2p6, right? So this is 2p6 and 3p6. So this is absolutely incorrect. That is a fluorine, no, chlorine having the highest as compared to fluorine, because in fluorine is smaller, repulsion is also present. Now, if I'm talking about gallium and thallium, so we know that in case of gallium and in thallium, right? So in case of gallium and thallium, atomic size of this is boron, Gajar in TL, right? So if I'm talking about gallium and thallium, obvious size of gallium is smaller, right? And this is the size of thallium. So out of this, you have to remove one electron, right? So which will of the following order of first ionization potential? So this will also wrong. So which one is the correct? If I'm talking about Sn and Pb, right? Sn and Pb. So Sn and Pb belong to which group, beta? Sn and Pb. So Sn and Pb belong to which group? That is 14th group. Okay, so out of Sn and Pb, which will show more ionization enthalpy? So obvious, due to the inert pair effect in Pb, their size become decreases. Their outermost electron will not participate present for the participation. Due to inert pair effect, the nucleus attract this electron. So due to this, here a large amount of energy is required to remove electron in the case of lead. So the correct answer is, that is option C, that is in tin and Pb. In Pb, we have to apply large amount of energy to remove an electron. Now, the second point is at isoelectronic point, right? So as isoelectronic point, what you have to calculate here is, at isoelectronic point, can you please tell me uh, the amino acid has. What is isoelectronic point? So this question is from the biomolecules. We all know that what is isoelectronic point. Isoelectronic point is the pH at which there is no net migration takes place, right? So at isoelectronic point, amino acid has a least viscosity, right? Because there is no net migration takes place. Their movement is very, very less. So at isoelectronic point, amino acid has least viscosity. So always remember this term, they having a least viscosity. So which option is correct, beta? That is option number A. So option number A is absolutely correct. Isoelectronic binds amino acid has a least viscosity. Now, this question is also very, very important. Try to understand this question as well. Okay. So what the question asks, beta? Sodium salt are highly soluble in water, hence undergo complete ionization in water. Now, if the freezing point of 0.3 molar aqueous NaXA solution is this, value of Xa. So this question is basically from the colligative properties, right? So what the data is given is the freezing point of the 0.35 molar aqueous solution. So we know that molality of the solution is already given. So molality, that is molality is nothing but small m, and this is equal to 0.35 molal, right? Now, the if the freezing point of this solution, yani TF is also given freezing point of the solution. So this is a nothing but freezing point of solution, right? So this is the freezing point of solution represented by TF. Then this is equal to minus 3.255 degrees Celsius. Okay. Now, sodium salt and highly solvent water undergo complete ionization, right? So sodium salt, we know that sodium salt, when they go complete ionization, it will give like this, right? So how will you actually calculate this value better? We know that delta TF is what? Delta TF is equal to KF into molality into I. So here we know that KF is already given 1.86, right? Kelvin kilogram per mole. And what is molality here? So molality is also given, that is 0.35. What is I? So this is the basic question here, right? So we know that I is what? So we already we have a relation for calculating I and alpha, that is I is equal to 1 plus n minus 1 into alpha, right? So I is equal to 1 plus n minus 1 into alpha. In the question, it is clearly mentioned that alpha, they will undergo complete ionization. Complete ionization means, oh, sorry. Complete ionization means beta alpha is equal to 100%, or we say this is 1, right? So this is 1. So I is equal to nothing plus this minus 1 plus 1 cancel. So I is comes out to be I is equal to when this is nothing but 1 plus n minus 1. So in case of this, we can write I as I is nothing but is equal to n only, right? So I is equal to n only. In such case, we can write as. Now, here we can observe that uh, what is the formula of this? So what is n here, beta? So n is basically what? NaXNA. So this is the sodium salt something. So how will you calculate? We know delta TF is nothing but 3.255. Understand? 1.86. What is I here? So I is equal to n. So what is n, beta? We know that n is equal to what? So n is nothing. For example, if you understand, let us assume if this is Na2SO4, then what is n in such case? Plus 1SO4, right? 2Na plus 1SO4. So let assume in case of NaAX, if they dissociate like x and plus 1. So what is the value of x here, right? So this associate to give x plus 1. This 1 represent the A. So you have to identify what is this, because this is NaXA. So here the value of x, here the value of 1. So this will become 1 plus x, right? So let's put the value n is equal to nothing but 1 plus x. So when you put this 1 plus x, how will you get this x, beta? This is 3.255 divided by 1.86 into 0.35, and this is equal to 1 plus x. So on solving, you'll get x is equal to 4. Right. So the formula is Na4A. Okay. So this is the formula. I hope you'll understand this. Suppose if in the question it will be like NaXA2, then how will you write? You'll write n is equal to nothing, but this will equal to 2 plus x, right? This is equal to 2 plus x. So you can write the value of n like this only. So this is also a good question, and this is not so hard question. This is average level question. So if you know the properties, if you know the concept, then you are able to solve this question as well, right? So this question is totally based upon colligative properties. I hope this is clear to you all. Anyone having any kind of doubt, you can ask beta. Now, next move to the next question. That is question number 4. So what the question number 4 basically asks, In question number 4, they are asking the species among the following which when brought near a charge column will attract. So this is very simple question, and this is actually based upon the dipole moment, right? Polarity of the bond as well. So the species among the following which when brought near a charge column will attract. So out of these three, four, you have to check which will show dipole moment, which will show zero dipole moment, which will show non-zero dipole moment. So in case of OCS3 and OCS3, we all know that their dipole moment is, right? In case of OCS3 and OCS3, their dipole moment is not zero, right? Their dipole moment is not zero. Why? Their dipole moment is not zero, beta? Because this is non-planar molecule. So in case of non-planar molecule, their dipole moment is absolutely not zero. Like these, we also molecule like OH, OH, they are also false in the example. They are the application of dipole moment. So they are also fall in the example of non-planar molecule and so non-zero dipole moment, right? And similar SH, when SH is present, they also saw the property like this, right? If I'm talking about IF7, they are actually they show zero dipole moment, right? In SO3, they also show zero dipole moment, and benzene also show zero dipole moment. So rest also 0, 0, 0 dipole moment. Only these, that is OCS3, OCS3 will show non-zero dipole moment. And due to this non-zero dipole moment, they having some polarity of the bond. Polarity means someone having positive and negative charge. Now when the charge come brought near to it, it attracted, right? Because they are already polar in nature. So the correct option for the question is that is A. So the right answer is A. I hope this is clear to you. Yes, beta. Anyone having any kind of doubt, you can ask. Clear है सबको ये? Okay, ठीक है. Now, in the next question, that is metachlorobenzyaldehyde on reaction with concentrated KOH at room temperature gives what? Right? So this is the metachlorobenzyaldehyde on reaction with concentrated KOH, right? So let me draw the structure of metachlorobenzyaldehyde first, right? So this is nothing but metachlorobenzyaldehyde. So this is chlorobenzene, and in meta position we have a aldehyde group, right? Like CH, and this is O. So this is CHO group is present. Now when we treat this with concentrated KOH. So when we treat this with concentrated KOH, what happened, beta? Basically, the formation of potassium metachlorobenzoate takes place. How? Like this, this chlorine remains the same, and this CHO is converted into nothing but CO. This is K positive and CO negative, right? So they will convert it into CO negative and K plus. After this, it will also give some product as this one as well as this one, right? So you'll understand this. This is nothing but this is a kind of Cannizzaro reaction, right? Cannizzaro reaction when the aldehyde which having lack of alpha hydrogen, when they are treated with concentrated NaOH, concentrated alkali, the formation of what takes place? The formation of alcohol plus the salt of carboxylic acid will take place. So just like this, it is a very much similar reaction of Cannizzaro reaction, right? So this is basically Cannizzaro reaction. Okay, so when they stated with this, the formation of COOK and the CH2OH will be takes place. So which one is the correct option? That is potassium meta dichlorobenzoate and metachlorobenzyl alcohol. So this will take place, right? So I hope this is also a good question and easy to moderate type of question is this, right? Now, so these all are the single correct answer type question. So this is the last one. This is the only in this sixth question, we have only one correct option for each question, right? So in this question, what they want to ask you, what you have to calculate. So you have to calculate the minimum volume of 1 molar HNO3 solution, which required to completely dissolve 95.25 gram copper producing NO. and the molecular mass of copper is already given. So this question is basically related to the reaction of copper with HNO3 as we seen in the P block, right? Okay, what happened? Basically, this is copper. When the copper is treated with HNO3, so this is the standard equation. We have to learn this. When the copper is treated with HNO3, the formation of copper nitrate, that is CONO3 2 plus 2NO plus 4H2O. So this is the balanced equation when the copper is treated with HNO3. Now it is already mentioned that 95.25 gram of copper. So how will you convert into mole? So will you convert into mole like 95.25 gram upon the molecular mass, that is 63.5. So this comes out to be 1.5 mole. So 1.5 mole of copper will produce 2 mole of NO. This is very much clear, right? So 1 mole of this produce this much of this. Now 1 mole HNO3 required to completely dissolve. So 1 mole of HNO3 is required. How much? So if the 8 mole require how many mole beta? Let's see. We can see from the equation that is 1 mole of copper, right? 1 mole of copper required 8 mole of HNO3. 8 mole of HNO3. So 1.5 means 3 by 2, right? So 3 by 2 mole of copper require 8 into 3 by 2. This is clear to you, right? This is equal to 8 by 8 into 3 by 2. So the 3 by 2 mole of copper require 8 into 3 by 2. Here also you can observe that how many moles of NO is produced, beta? Only 2 moles of NO will be produced, right? So 2 moles of NO and 4 moles of H2. They already mentioned in the question that is calculate the minimum volume of 1 molar HNO3 solution required to completely dissolve 95.25 gram copper producing NO. So the copper producing NO. So this will be equal to nothing but 8 into 3 by 2 divided by 3 only. So it comes out to be 4. So this is equal to 4 mole. Now, we know that what is this? We know that this is concentration is equal to 1 molar is equal to molarity into volume in the liter, right? So what is the molarity given? The molarity is nothing but 1. And what is volume? That is we have to find. So this V comes out to be, 4 liter, right? So this V comes out to be 4 liter. So this is the correct answer. I hope this is clear to you. Clear है सबको समझ आ गया ठीक है so this is volume is nothing but 4 liter so 4 liter is the correct answer for this question. Now let's move to the seventh question. So this question having more than one option correct, right? So these are the more than one question correct type of this. So you have to identify which of the following statement regarding refining is are correct. So for the refining, this question is from metallurgy. So you have to identify the which statement is absolutely correct, right? So the first one, zone refining is based on the principle that impurities are more soluble in molten state. This one is absolutely correct. These are the basic definition of the zone refining. In liquefaction, the melting point of metal should be less than that of impurity. This is also absolutely correct one because in the liquid form, or we say when the liquefaction takes place, the melting point of the metal should be less than that of impurities. Now, in electrolytic refining, the more basic metal remain in the solution and the less basic ones go to the anode. But this one is absolutely correct again. Now, in Wankel method, the metal iodide is decomposed to tungsten filament depositing pure metal. So this is also correct. So these all four options are totally, uh, the method based and they are directly related to their definitions and their procedure, right? So out of these, all the four option are absolutely correct. That is option A, option B, option C, and option D. So all four options are absolutely correct. I hope you'll understand this and learn from this question, because these all points are very much correct related to their method of purification, Jones refining, electrolytic refining, and Van Garkel method. So these all points are absolutely correct. Now, in question number 8, you have to identify the right. So what they ask, which of the following are linked to the reaction? Linked to the reaction. So क्या क्या बन रहा है? Let's see. सबसे पहले x बना के देख लेते हैं कि x बनेगा क्या. So we know that this is nothing but this is a Friedel-Crafts alkylation, right? When benzene is treated with CH3Cl in presence of AlCl3, this will be known as Friedel-Crafts reaction. So this is nothing but Friedel-Crafts alkylation. Now, here one important note, because here what is there? CH3, CH, CH2, and Cl. So we know that this will become positive. This will become positive charge. This CH2. So this will charges this electron, and this will become the positive one, right? So what the reaction takes place? That is, this is benzene. This is benzene, and at benzene, it will come like C. It is surrounded by CH3, right? This C is surrounded by CH3 and CH3, again CH3. So this will be surrounded at C, CH3, CH3, and this is also CH3. CH3. So this will formation will take place. So this one is absolutely correct, right? Next, this reaction is also known as the Friedel-Crafts reaction. This is also absolutely correct. So B and C are correct. Carbocation formation takes place. Yes, carbocation formation takes place. Methyl shift takes place. So no, here there is no methyl shift, right? So here is no hydride shift is present here, right? So there is no methyl shift in this reaction. So when this is treated with AlCl3, first of all, the carbocation formation takes place, right? If you see the mechanism, we can observe that when the CH3 and this is CH, this is CH2, and this is Cl, and this is also CH3. When they are treated with AlCl3, we know that AlCl3 acts as the Lewis acid. They have a tendency to accept electron. So they will become like CH3. This will be C. This will be like CH3, CH3, CH, right? So this will be like CH3. This is CH. This is CH2 having positive charge, right? So this having the positive side. So in this, hydride shift takes place, and this hydride shift, this H, right? So this will become CH3, C positive, and this will be CH3, and this is also CH3. So in this, hydride shift takes place, not the methyl shift, right? So the three option, that is option A, option B, and option C, these all three statements are absolutely correct. I hope this is clear to you. This is totally based upon the Friedel-Crafts mechanism, Friedel-Crafts alkylation. Good? No. Let's move to the next question. That is question number 9. So in this also, this is a multiple answer type question, right? So you have to identify which option is correct. A lead storage cell is discharged, which causes the H2SO4 electrolyte to change from a concentration of 40% by weight density is equal to this to 28% by weight. Now the original volume of the electrolyte was 1 liter. Identify the correct statement, right? So let's see. For this question is from electrochemistry, lead storage secondary cell, right? So a lead storage cell is discharged with the cause the H2SO4 electrolyte to change from a concentration 40% by weight to 28% by weight. So their concentration is changed, right? So initial concentration is what? So initial concentration of H2SO4 is nothing but 40%. right? So what is the mass corresponding to this? Can you say what is the mass corresponding to this 40%? So initial mass of the H2SO4 in the solution, initial mass of H2SO4 in the solution is nothing but multiply its density, that is 1 to 6 gram, and multiply by 0.40%. Right, this is the initial concentration, right? So it comes out to be 5.40 gram of H2SO4. Say, let us assume when their concentration is changed from 40 to 28%, there will be change in the this one, right? So how will you write this? Like, so when the W gram of H2SO4 is consumed, then what their weight comes out to be? So let's say W gram H2SO4 is is consumed, right? So let's say W gram of H2SO4 is consumed. So total 504 gram out of W gram is consumed, divided by, we have to calculate the mole fraction, right? So it is equal to nothing but this is 1260 minus W, right? 1260 minus W and plus 18 upon 98 into W into 100 is equal to 28, right? So this is the 28% by weight. So we can calculate like this. Okay. On solving, what you will get weight is equal to 28, or we say weight is equal to nothing but 196. This is the W. Okay. Now number of mole of H2SO4, that is 196 upon 98. This will equal to 2. So 2 mole of H2SO4 consumed. So 2F charge pass. So 2 mole of H2SO4 consumed, right? So the 2 mole of H2SO4 consumed. What does it mean? It means 2F charge is passed. 2F charged is passed, right? 2F charge is passed. Or we say 2 into 96,500 is equal to 1.93 into 10 ki power 5 coulomb, right? So this one is also correct, right? So this is nothing. This is the correct one. 2 into 1.93 into 10 ki power 5. So total charge released from the anode to the cell is 1.93 into 10 ki power 5. This one is correct. A total 2 moles of H2SO4 have been created. Yes, this one is also corrected. So the mass of electrolyte solution has decreased. Initially, it has mass 504. After this, they have a mass 196. So this one is also correct. And the overall cell represented PV, so this one is also correct, right? So all the option, that is option number A, B, C, and D, all fourth option are correct, right? So I hope you understand this thing, how I calculate this basically. Okay. Now, let's move to the next question. That is question number 10 basically. So what the question number 10 asks with 10. This question is very, very simple. So try to understand this question. In this question, which of the following reaction can we use to produce boric anhydride? Right. So out of the following, you have to identify which of the following reaction you will use to produce boric anhydride. So can anyone tell me what is the formula of boric anhydride? Boric anhydride, right? So can anyone tell me how will you write the formula of boric anhydride? So in boric anhydride is nothing but like they having a structure like O, B, O, then again B, then double bond O. This is anhydride, right? So this is called boric anhydride. That is BO3, B2O3, right? This is nothing but B2O3. Sorry. This is called boric anhydride. So out of the following, you have to identify in which of the following, out of the fourth option, in which we will obtain boric anhydride, right? So when you treat B2S6 plus 2CO, will you obtain? When you treat B2S6 plus 3CO? No. S3BO3? No. So in this, we can't obtain this, right? When the diborane is heated with oxygen, because here we'll get O2, na? So we'll get this, right? Similarly, when the borax is undergo a strong heating, then we also get. So only these two options, that is option number C and D. So only these two options, that is C and D, will get the boric anhydride. Is it clear to you? Or any doubt related to this question? No? Everything is clear? Good. Now, which of the following compound can exhibit optical isomerism? So you have to identify out of the following, which of the following will exhibit optical isomerism, right? So which will show optical isomerism, beta? Obvious, it is clear from this all fourth option, that is this one will not show optical isomerism, right? Why they are not so optical isomerism? For optical isomerism, chirality is the requirement also. The presence of at least one chiral carbon is important. Here we can say that this carbon, this can CH3 group, and this is H group, and this is another group. So they have having two different group, right? So chirality must be present so that they can show only optical isomerism, right? So this will also show because these will present in the two different state, like they are present in the wedge and S shape. So this will also show, this will also show. So this is A, B, and D. So A, B, D, right? A, B, and D. These three are show optical isomerism, where the option C will not show optical isomerism, right? So this is the important one. Just remember this. Now, this question is very important because this is from a structure of atom, right? So this is from a structure of atom. So try to understand this question, how we're going to solve this question. Okay, so this is question number 12 basically. And what they ask about for the hydrogen atom, the wave function of electron is given by 1 upon 81 under root 2 pi a naught square, sigma, sigma minus sigma, sigma e minus sigma 2 cos theta, where sigma is the 2z r upon na naught and A naught is equal to 5.29 angstrom. Select the correct option about the orbital to which this electron belongs. So you have to identify the orbital from which this electron belong, whether it belong to the 3pz, right? So it will belong to the 3pz. How will you know? Since the angular function, that is A cos theta, is for orbital pz only, right? And power of sigma is also here. Power of sigma is nothing but also is equal to 1. So it means L is equal to 1. So let me derive the formula, right? So angular function is equal to cos theta, right? So the angular function here, angular function, that is cos theta, is directly proportional to the cos theta, right? And this is cos theta for orbital pz, orbital pz. So this one is correct. Option number A. Option number A is absolutely correct. Now here the power of sigma is 1 only. Power of sigma is 1. So from this we can conclude L is equal to 1. So L is equal to 1 here. Or we say this is p orbital. This is p orbital. So here the power of sigma is 1, or we say L is equal to 1. So we can say that this is a p orbital, right? Now you have to identify the n also. So we know that in this case n minus L minus 1, right? So what is this n minus L minus 1? So this is the radial plane, n minus L minus 1. So for one radial node, put radial node is equal to 1. So for one radial node, what is the value of this one? So n comes out to be 3 because L is already 1. So 1, 1, 2, 2. This will become 3, right? Minus 2 and this plus. So this will become plus 2 and 1, that is 3. So n belong to 3. The orbital is 3pz. Confirm this orbital is 3pz. So option A is absolutely correct. Now, it has only one angular node. So yeah, right. Because L is equal to 1 here. So it have only one angular node. So this is also correct. Right. And on only one radial node. So we have the formula finding radial node, right? N minus L minus 1. So this N is what? 3. L 1 minus 1. So 3 minus 2 is equal to 1. So this is also correct. This is only one radial node. Nodal plane is xy plane. So you have to find that whether the nodal plane is xy plane. So obvious xy plane because this is a PZ now. So PZ means xy plane is the nodal plane where probability of finding electron is 0. So this question is easy, but you have to learn this thing. If you want know this thing properly, then you are not able to solve the question because from this equation only you got the value of L, right, and PZ orbital. So you must know this thing so that only you can write this, right? So from this question, what we learned that angular function is directly proportional to the cos theta, which is equal to orbital PZ. So for PZ only, this cos theta is given. Now power of sigma is 1. It indicates that just wait, right. So the power of sigma is 1, which indicate that just let me just apply the power plus. Give me 2 minutes. Okay, no, fine. So from this question, we learn the power of sigma is on. So we can say L is equal to 1 there, right? So L is equal to 1. Once we know this L is equal to 1, then we can easily calculate angular node, radial node, whether it is a three-paged or not, or nodal plane is XY plane. So or the fourth option, that is A, B, C, D are correct. So all four options A, B, C, and D are absolutely correct. I hope this is clear to you all. Good. Now, let's move to the third section, right? This is totally, numerical based question. So try to understand this thing. Out of this, which will is correct and not. So this is totally numerical based or integer type question. So number of reaction that will produce black precipitate among the following. So in which of the following reaction the black precipitate will be formed? So identify this, right? So in out of this seventh reaction in which black precipitate will be formed, right? So we know that what the reaction is basically. So in the reaction, this reaction is basically like what happened, right? What happened when the silver is treated with sulfide? So can anyone tell me which one is going to be correct answer for this? Can anyone out of these seven, which one will right correct? Whether it will be two, three, or you know, anyone? No. Okay, let me. We know that when the first, when the Bi3, this will treated with 3OH, right? When the Bi3 is treated with the 3OH, it's always, right? When the Bi3 is treated with H2S, this will, where is Bi and H2S, right? So when the Bi3 is treated with 3H2S, then the product is formed and this will form black product, right? So always remember this will form like Bi2 and S3, which is black in nature, right? So this will be black in nature. Now, in another case, like when the Bi plus 3OH, whether it will form or no. When the FeCl3, this will form, does not form. Now, out of this, BiOH and SnOH4 also, they will also form like a structure like this, right? When the Bi3 is treated with Bi3 is treated with 3OH, they also form this structure like black, right? So out of these, only three reaction, three out of this seven, we have a three in which black precipitate will be formed. So just remember this. Out of this, only fourth one in which only three is the correct in which the black precipitate is formed. So always remember this in which of the following. Basically, when the Ag plus is treated with this in Ag plus, right? When the Ag plus H2S, then also black precipitate will be formed. Like when the Ag is treated with H2S, right? So what the formation takes place, beta? Can you tell? That is Ag2S, like Ag2S NH plus. Here also black precipitate form, right? So in this case also black precipitate is formed. Similar when the Bi3 is treated with 3I, when the Bi3 is treated with 3I also, there is formation of black precipitate, right? Is anyone having black precipitate? No. So only three options. That is this one. That is the first one, and this one, and the this one. So only these three. We have a three in which black precipitate will form. I hope this is clear to you. Right. Now, this one is going to be very important. So you have to identify in this question total number of alkene possible by the dehydrogenation of 3-bromo 3-cyclopentane hexane using a alcoholic KOH. So we know that this is the elimination method, right? So this is the elimination method, purely elimination method. So you have to identify in which of the following this will be happening, right? So let's see. What the question basically is, the total number of alkene possible by the dehydrobromination of 3-bromo 3-cyclopentyl hexane. 3-cyclopentyl hexane, 3-bromo. So let me draw the structure of this. And this is pentyl hexane, right? Okay. So this will be now 3-bromo. So we have to 3-bromo. So this is carbon number 1, carbon number 2, this is carbon number 3, 4, 5, and 6. Right? So 3-bromo 3-cyclopentyl hexane. Right? Pentyl hexane. So this is the formula. Now, in 3 position we have a bromo. So this is the structure of 3-bromo 3-cyclopentyl hexane. Cyclopentyl hexane. Now, when this treated with KOH, we know that in KOH, KBr plus H2O forming removal, dehydration takes place. So dehydration from which position beta? Basically, this is group. So this is alpha carbon. So this is beta carbon, right? So this one is beta carbon. Now, the formation of what takes place? Formation like, okay, so this will become C, double bond C, C and C. This is C, C. Right. So this will take place. This is known as EZ isomer type. This is known as 2. Similar, one another important product is total how many isomers. So we have one isomer like this. Another isomer is like this. Another isomer is like this. This will become C, 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 and C. Right. And the another isomer like, okay. So this is the way, this. So this is a total that is E by Z 2 and this is 1. Right. So this is the total isomer will get. So total number of isomer will get is nothing but total of 5 isomers. Right. So total of 5 isomers. So 5 isomers is the correct. 2 isomers of this E and Z, two isomers of this EAZ 224 and one isomer of this. So total 5 isomers, right? So total number of isomers that we'll get is 4 isomers. I hope this is clear to you, right? Now let's move to the next one. This question is basically from the chemical kinetics. The rate of a reaction gets doubles when the temperature changes from 7 degrees Celsius to 70 degrees Celsius. We know that whenever there is a rise in the 10-degree difference, then the rate of reaction becomes double. Now, by what factor times will it change for the temperature changes from the 17 degree to 27 degree, right? So we know that thing, we can easily calculate. We know that this is nothing but ln, this is K1 is equal to EA upon R, and this is equal to 1 upon T1 minus T2, right? T1 minus T2. So what is the first statement? The rate change again double. And K1 rate of become this ln become ln2 when the EAR, when the temperature changes from this to this. It means 7 degree to 17 degree. So what is 7 degree means 273 plus 7, right? So it will become in Kelvin, we can calculate now. In Kelvin, what is the value is 273. 273 plus 7. This will become 280. This is 280 Kelvin. And this will become T2, T270. So 273 and 7, 280, 290 Kelvin, right? So this will become 290 Kelvin. So this is the first statement. What will change for the temperature from 17 to 27? So let write as log K2. Okay. This will become EA upon R and temperature 17 to 27. So 1 upon 290 minus 1 upon 300, right? This is equation number 2. So just divide this two unknown. So we can divide like ln K2 upon ln 2, right? Is equal to EA can get cancel out each other. This will become 280 into 290 upon 290 into 300. So this will 290 get cancelled. So it will become 280 upon 300, right? So this comes out to be ln K2 into ln 2. So we'll easily calculate. So this is very much simple question, right? So this is very simple question. K2 comes out to be 1.91. Right? So 1.91. So by what factor this will increase? By the factor 1.9. I hope this is clear to you. Got it? Good. So this is the very simple question and it is totally based upon the activation energy. Right? So this is the fact. Now, let's see this question. This one is also very important. That is question number 4, right? So let's see what the question number 4 basically is. This is from CFT only, right? So let's understand what the question basically asks from you. So in this question, the number of splitting configuration against the given complex that are incorrectly. So we know that in case of FeCN6, if CN is a strong ligand, then this energy gap is very much. So what is the oxidation state of Fe? Here the Fe is in Fex. This will become X minus X is equal to minus 4. X is equal to 2. That is plus 2. In plus 2 from Fe having 3d6 electronic configuration. So 3d6, 1, 2, 3. This will be 4, 5, 6. So this is absolutely correct because we know that Cn is a what? Cn is a strong ligand, right? So if the Cn is a strong ligand, then the pairing done in the T2G first. If the fully T2G is filled, then only we'll go to the Eg level because the energy difference is very much. So this is the incorrect filling. Now, in case of MnNH3, right? MnNH3. So we know that Mn having the oxidation state of 6 and is plus 2. So Mn in plus 2, they having 3d5. Like so T2. So we have a 1, 2, 3, and this one. So ammonia is considered to be weak ligand as we compare to any other, right? So this will the correct one, that is 1, 2, 3, and this is 4, 5. So this is correct one. Now, NiCl4. So NiCl4, this is a tetrahedral. So in tetrahedral, this is absolutely correct. Incorrect, right? Because this splitting is not possible in tetrahedral. In tetrahedral, Eg comes downward and T2G comes upward. So this is absolutely incorrect. Now, PTCl4. So in PTCl4, this will be possible. Repulsion. This is 1, 2, 3, 4. This is yes. So this is in case of EG. EG is downward. Yeah, this is correct. So this energy gap is very different. So 1, 2, 3, 4, 5, 6, 7, and 8. So this is absolutely correct. So this one is correct. This one is correct too. And the next one is that is COH2S3. So here the ligand is weak. So total 336 ligands are there, the T2G. So this will be the so this one is also incorrect, right? So this is also incorrect. So this is incorrect, and this is incorrect. This is incorrect, and only this one is correct. And NH3 is considered to be strong ligand. So this is also incorrect. So out of these, 1, 2, 3, and 4. So 4 having incorrectly matched. So number of the splitting configuration against the given complexes that are incorrectly is 4. Right? Only the fourth option that is absolutely correct. Rest all the options are incorrect. Right? So this is also a very easy question. Is it clear to you? Or anyone having any kind of doubt, you can ask. No? It's all clear? Very good. Now, let's see the next question. That is number of moles of CrO3 required to oxidize 6 mole of 2-heptanol, right? So the number of moles of CrO3 required to oxidize 6 mole of 2-heptanol. So what is the number of moles required basically, beta? That is that is 4 moles, right? So only the 4 moles will required to oxidize. Can anyone able to write the answer of this question? How 4 moles comes into the picture? That is the number of moles, right? So number of moles of CrO3. Can anyone? Hmm. Anyone tell me? No? Okay. So I'll explain you, right? Let's draw the structure of 2-heptanol, right? So 2-heptanol. So just draw the structure of 2-heptanol so that you are able to understand this thing, right? So number of moles of this Cr2 oxidized to require 6 mole of 2. So how will you write the structure like this, beta? Can anyone tell me what is the way to write the structure of this? No? Okay. So I'll tell you. So the correct answer is for this question is 4, right? So the correct answer for this question is 4. So how will you write this? Just understand this thing so that you are able to write this. First of all, number of moles, CrO3. So what is this CrO3, beta? So this CrO3 is nothing, but this is CrO3. And this react with heptanol. Heptanol is what? That is CH3, CH2, 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 right? 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and again CH2OH. So they ask how many mole of this will required to produce this much, right? So can you tell? So it will require only 4 moles, right? So it will require only 4 moles. So number of moles, that is 4 moles of CrO3 is required to oxidize 6 mole of 2-heptanol. That is 1, 2. That is their OH is here, right? So OH is here only. That is 2-heptanol. So 4 moles of CrO3 is required for this. Now, what the next question is asked, beta? This question is totally from thermodynamics, right? So let's see the question. Calculate the delta G, that is a Gibbs free energy, right? So we have to calculate the delta G for this reaction, right? So calculate the delta G in kilojoule per mole of the reaction, H2 301 bar, H2 200 bar at given H2 is an ideal for H2, PM is given, and temperature for entropy is also given. So we know that, what we know beta, we know that delta G is what? So delta G is nothing but is equal to delta H minus T delta S, right? So delta G is equal to delta H minus T delta S. Now, we also know that delta G is equal to N, and at constant pressure and mole, this is T2 minus T1, right? Minus this T2, S2, T1 and S1. So this is also we know. Now here delta S is already given. What is delta S? So delta S is given like delta S is nothing but S of H2 at 600 Kelvin, 2 bar, minus entropy of H2 at 300 Kelvin and 1 bar, right? And we know the formula of delta SS. This is nothing but NCPM, right? ln T2 over T1, right? Minus NR, NR ln P2 over P1, right? ln P2 over P1. So just put the value. We know all the required value, right? So this will comes out to be, on solving, you'll get delta S is equal to, right? So once you get the value of delta S, right? Once you get the value of delta S, which is equal to what? When you solve this, you'll get the value like 1 into 28.314, that is CPM is already given. So it comes out to be 144, right? It comes out to be 144.07 joule per Kelvin, right? And more. So just put the value in equation 1, that is delta G. What is delta H here? 1. And this is nothing but 28.314. And this temperature difference is what? Temperature difference is 600 minus 300 minus the value of entropy, that is 600 into 144 minus 300 into 130, right? So on solving, you'll get like 38.90. This is in kilojoule per mole. So 38.90, this is the correct answer for this question, right? So 38.90. So far we'll discuss in all the question in the paper 1, right? So we already discussed all the question of the paper 1, then what type of question they were asking in paper 1. So from after 2 minutes, we are going to start the discussion of paper 2 as well. So we'll see the paper 2 solution as well, which type of question they are generally asking paper 2, and how will you actually solve such question, right? So let's see how will you solve such question and all, and try to understand this thing. Okay, so let's see which type of question they are generally asked in paper 2. Okay, so paper 2, the first question is, as we can see that okay, so 1 mole of an ideal monatomic gas undergoes process from state at A to C as the follow, right? State A to state B to state C, right? And the process name is also given. You have to identify the correct option, right? So you have to identify the correct option. Which option is correct, right? So you have to identify the correct option for this only. So let's see which option is correct. State A. So we know that state A means what? State A, state B. And this is isocoric, right? So this is state A, this is state B, this is isocoric process. Now, what is isocoric process? Isocoric process means at a constant volume. So this is a constant volume process known as isocoric process. So this is state A. and you have to go from state A to state B, and this is a isochoric process, right? At constant volume. Now, pressure of a gas at state B is 280. Whether it is true, so we know that PV is equal to constant, right? So PV is equal to constant, or we say PV is equal to nRT. So in case of isochoric process, this V remain constant. So this nR upon V, this whole term remains constant. So we can write P upon T is equal to constant. So we can write now P1 over T1 is equal to P2 over T2, right? So what is P2 here? So P2 is nothing but P1 into T2 over T1. So what is the P1? P1 is already given 1 atm. What is T2? Is already given 600 Kelvin. T1 300 Kelvin. So pressure become 2, right? So this is absolutely correct. The pressure of the gas at state B is 2 atm. So this is correct, right? Now, it will say delta HB is equal to 900 Kelvin. And if from first position to second position, delta H. So what is enthalpy? So enthalpy, heat content of the system at constant pressure, right? Here the pressure is not constant. So this will be absolutely wrong, right? Because delta H is what? Delta is nothing but energy at constant pressure only. So between A and B, pressure changes. Pressure changes, P and PB. So we can say that this statement is absolutely wrong. Now, delta UAC from A to C, that is A to C, that is from isochoric, that is a constant volume, and adiabatic. So from A to C, this is 6300 kilojoule. Whether it is true? Yes, this will be true. Because how will you calculate this? We know that delta U is a function of temperature only, right? So from the first law, delta U is equal to Q plus W, right? So in the first process, that is from A to B, that is isochoric process, the work done is 0. So in this process, delta U is equal to Q only, right? There's a heat supply, right? This is from A to B. Similar, from B to C, this is the adiabatic process. So from B to C, adiabatic process means what? Delta U is equal to Q plus W. Now again here, from B to C, here Q is 0. So delta U is equal to W, right? So this is from B to C. This is from A to B, right? So from A to B, delta U is equal to Q, and from B to U. So how will you calculate Q here, beta? In case of isochoric process, how will you calculate Q? So we know that for calculating Q, what you need to know? Q. We know that we can easily calculate heat of the system. So for heat of the system, we'll get to know how the value of is comes out to be. So the value is like UAC 63 kilo calorie, right? And we also know that delta UAC is an internal state function. So delta UAC is equal to internal energy of C minus internal energy of A. So just subtract this two value, internal energy at C at internal energy at A, you will get the value. WBC, work done from B to C is 5400 kilojoule. Whether it is true? Yes. That is the work done from B to C. That is B to C. Against the adiabatic reversible process, work done is comes out to be this, right? Because the temperature is given, pressure is given, you have to calculate, and you can calculate. Because you already know P2 here, right? So you will calculate this. So only option B is incorrect, rather than A, C, and D. All these three options are absolutely correct. Now, the next question. Which of the following statement are correct? At ordinary temperature, oxidizing strength of HClO3 is greater than HClO3. Absolutely right. As the number of O increase, the oxidizing nature also increase. So at the ordinary temperature, the oxidizing strength of HClO is greater than HClO3, right? Now, fluorine can decompose water with liberation of iogenide oxygen. So this is also correct. HI is a stronger acid than HBr because of the low dissociation energy. This one is also correct. In aqueous solution, chlorine is a stronger oxidizing agent than fluorine. This one is wrong, right? because in aqueous solution, fluorine is the stronger oxidizing agent. So this one is incorrect. Rest all, that is A, B, and C. Both are correct. Now, which of the following carboxylic acid could not be resolved by the reaction with an enantiometrically pure chiral amine? So, which of the following carboxylic acid could not be resolved by reaction with an enantiometrically pure chiral amine? Right. So, you have to identify this, right? So, which one is beta? That is this one, A, B, and D. So, this carboxylic acid, COOH, that is, so this carboxylic acid could not be resolved by the reaction with an enantiometrically pure chiral amine. Right. So, only these three options. Now, this one is very important question from the ionic equilibrium. Right. So, what the question asks, try to understand this thing. In this question, they are saying 0.1 mole of H2A as solution is titrated with 0.1 molar of NaOH solution in the presence of methyl orange and phenolphthalein indicator. Reaction are as follow. H2A plus NaOH give you NaHA plus H2O, that is methyl orange, and NaHA plus NaOH will give Na2A plus H2O phenolphthalein. Given that Ka1 H2O is 10 to the power minus 3 and Ka2 is 10 to the power minus 6. Select the correct analytical statement about above titration. Okay. So you have to select the correct analytical statement about the above titration. Now, 100 ml of H2A solution is titrated with the 100 ml of NaOH in presence of methyl orange, and the final pH becomes 4.5. Similarly, 100 ml of H2A solution is titrated. So let's see the solution for this question so that you can understand this. Now, in this question, it is clearly mentioned that H2A, H2A plus NaOH, H2A plus NaOH. This will react to give NaHA plus H2O. Now, 0.1 molar of, or we say 1 mole, will give 0.1 mole and this one, right? Okay. Now we have to calculate the pH. So pH is equal to what? That is pKa1 plus pKa2 divided by 2. So we get the value like 3 plus 6 divided by 2. That is equal to 4.5. Right? 4.5. Now in the second case, this is for the first case, right? This is for the first case. In the second one, for the second option, we'll say H2A react with 2 NaOH to give Na2A plus H2, right? Na2A plus H2. Now, 0.1 molar or 100 ml, or we say 0.1 molar or 200 ml is equal to 10 upon 300, or we say 1 by 30. Clear? This is equal to 1 by 30. Now, A minus 2 react with H2O, they form Ha negative plus C alpha, where alpha is the degree of dissociation. Right. Now, this is C1 minus alpha. This will form C alpha, C alpha. So what is KH here? This is Ha negative, OH negative, H positive, A minus 2, and this is H plus. Right? Just put the value. This is nothing but Kw upon Ka2. Kw we all know this is equal to 10 to the power minus 4. This 10 to the power minus 6. So this will come 10 to the power minus 8. Right? This will come 10 to the power minus 8. This one is absolutely correct. Right? So which option, that is out of which option is correct, beta? So fourth option, the A, B, C, and D. So all four options are correct. So all four options are correct for this question. Right? So I hope this is clear to you. Now, What ask in the fifth question? What is the fifth question basically is? So in the fifth question, they are asking which of the following statements are corrected, right? So which of the following statements are corrected? The first one is anhydrous MgCl2 cannot be prepared by the heating MgCl2.6h2. This one is absolutely correct. Anhydride calcium chloride is used in drying gases or organic compound, but not NH3 or ethyl alcohol. This one is also correct. Solvay process used for the preparation of Na2CO3 but not for the K2CO3, bilkul, because K2CO3 is soluble and NH3 are insoluble, right? So this is absolutely correct. KOH is preferably used compared to NaOH for absorption of CO2 because KHCO3 formed is soluble, whereas NaCO3 is springly soluble, and therefore COP is the tubes of the apparatus used. This one is all the four statements. That is absolutely correct, right? So all the four statement is correct. Now, question number 6. The product obtained during the reaction is which of the product is obtained when this will treated with the oxygen having isotopes of oxygen having 18, and this will react with H3O plus. So which will form takes place beta? Yes, this one, that is B and C. So only these two product will be take place. Now, this question is very important. So try to understand this thing. Yeah. By the sample of a ground state, right? By the sample of a ground state atomic hydrogen, UV light of energy is observed. So how much energy absorbed here, beta? That is 13.6 into 48 on 49 electron volt, right? Is observed. How many different wavelengths will be observed in the Balmer region of the hydrogen spectrum? So you have to identify the Balmer region. So we know that n is equal to 1 for Lehman, n is equal to 2 for Balmer. Balmer. Here n is what? Here n is what? If you're comparing with the standard equation, it will come out to be 13.6 into z square upon n square, right? So n square means that is equal to 7. So 2 to 7. So how many transition takes place? That is a 5, right? So absorb. So how many different wavelengths will be observed in the Balmer region of the hydrogen spectrum? That is 5, right? Now you have to calculate the spin only magnetic moment value of the CrCO6. So we know that in case of CrCO6, right? So Cr having zero oxidation state. Cr having zero oxidation state. So no unpaired electron is there. We know that magnetic moment is under root n plus 2. So if n is equal to 0, then u must be 0. So what is the value is? Value is G. Now, in this, X represent the total number of alkene which on reaction with dilute to 4 from A as a mother product, and Y represent the total number of alkene which on reaction with dilute to 4 B as a major product. Then find the value of Y and X, right? So when they are treated with X, the formation is same molecule, that is 2 minus 2, which is, comes out to be 0. So what is Y minus X? Y minus X is, comes out to be 0. Now, this question is from states of matter. That is a real gas, right? So what the question asks basically, that is a real gas has a molar volume 1.00003 times greater than the ideal volume, right? In experimentally condition at working pressure and temperature of this. Boyle's temperature of gas was observed 200 Kelvin. What is the value of the fluid volume in liter or mole of gas? Consider value of R is this, right? So how will you find this? We know that Z is equal to 1 plus B minus A upon RT. Right? Now, PVM is also equal to ZRT. So 1 upon VM equal to P upon ZRT. Right? Now put the value in this. So this will become Z 1 plus B minus A upon RT and this become, what will become? 1 plus b minus a upon RT, and this will become P upon ZRT. Okay, so on solving, well, what you will get? You will get B is equal to nothing but T upon T minus TB multiply by Z minus 1 ZRT upon P. So just put the value. So putting the value 300, 300 minus 200, 0.003, 1.003 upon 1, right? Into 0.08 into 300, right? So if you put the value, you'll get B is equal to nothing but 0.02 liter per mole, right? So you have to calculate this. What is the value of excluded volume? So this comes out to be the excluded volume, right? So this is how you can calculate excluded volume in this case. Okay. So this question is basically from the real and ideal gas equation. So find the number of oxy acid having the peroxy linkage. So you have to identify the number of oxy having the peroxy linkage. So out of this, which will having a peroxy linkage. So this one having peroxy linkage, if you draw the diagram like PO, PO, right? This is OH, OH. So how many O they having? H2, they have been left with 1, 2, 3, 4. So they have been left with 4 OH now. So 1 OH also possibility there. Yeah. So how much? 1 oxygen, 2, 3, 3, 6. So 2 oxygens are there. So this is called peroxy linkage. Right? This is called peroxy. So this will be in H2PO and same as in case of this, right? So total H2, H2O8. Right. So this will be the total number of peroxy. So how many? So only two having the peroxy linkage. So out of this many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, only two having the peroxy linkage. Okay. Now, when this treated with the number of carbon atom present in P, so you have to identify the number of carbon atom. So here also number of carbon is 1, 2, 3, 4, 5. Right. So when you treat with SCN, so there's the addition of like how the formation takes place better. This will be like OH and this will be the CN. Right. And then again, they are all are same. That is CHOH4, 4, and this will become CH2OH. Here only na 1, 2, 3, 4, 5. So there will be 6. So total number this will be 3, 3, 4, 5. This will become 4. So this will total number of carbon is equal to 6. Right. So total number of carbon in this question is 6. Now the first one is this one is very important. Ki aqueous and KiO3 aqueous mixed together in presence of HCl to form I2 and KCl and liberated I2 required. Right. So you have to identify the value of 3x minus 2. So let me write the equation first. When the Ki is treated with KiO3 plus some amount of HCl, it will give this I2, KCl, H2. Let me write the stoichiometric coefficient. This is 5. This is 6 HCl. This is 3 I2, 6 KCl, and this is 3. Right? So this is 5 Ki plus KiO3 plus 6 HCl gives 3 I2 plus 6 KCl plus 3 H2. Now, this I2 millimole of I2 is given 5 millimoles. 5 millimoles of this I2, this react with 2 Na2 S2O3 to give 2 NaI plus Na2 S4 and O6. Right. So what the value of comes out to be? So X comes out to be that is 25 upon 3 and y is equal to 10. What is the formula? 3x minus 2y is equal to 5. Right? 3x minus 2y is equal to 5. Put this now. 3 into 25 upon 3 minus 2 into 10. Right? So you will put like this. Understand? How will you get the formula? Hmm? So this is how you'll get the formula of this, right? So this will come out with 75 minus 2, and this is equal to this value. So this is how will you get this. I hope this is clear to you, right? So this is equal to 5. Move to the next question. That is, find the number of ligand which are stronger ligand as compared to ethylene diamine. That you have to identify the ligand which is stronger than EM, right? So which of the following is stronger than EM? We have only two, like CN and NH3. So only these three, two, CN, NH3, sign. Mm, no, no, no. So ammonia is weaker than this. So CN and NO2. So only these three two are stronger than this, right? So this is the correct one. On the similar basis, this one, a sample U having half-life is given, is found to contain 23.8 gram of uranium this and 20.6 gram of Pb2. If the age of the ore is thin, then find the value of 2. So I hope most of you solve this question. This was a formula-based question and very simple to use. So this is a pura totally formula-based question, which answer comes out to be 9. So try to solve this question. If you feel any difficulty, I'll explain you in the next class, right? So we already cover all the question. Okay, so let's see so let's see some important things. And in next class, we are going to start our new chapter, that is thermodynamic and thermochemistry, right? So try to solve this question. We'll also try to focus all this question, try to understand this question in a good way. So this is your first exam. Prepare well for the next one, that is on coming Sunday, right? So try to work on this. Okay. So let's meet in the next class where we'll discuss all this. Till take care and just read it.